So we finished up most of the stuff we were doing yesterday with law of sines, because we looked at several cases where we only had one triangle. We looked at a case where it's no solution, and then we looked at two cases where it was two. So we have those cases. Now, any of those cases, it really doesn't make a big difference. It's just we use that flowchart to tell us how many solutions we have. And it's really nice if it's no solution because, well, we really didn't have to do much. Now, you won't need it for today.
Okay.
Now, an area of an oblique triangle. So using the law of sines, now we know that the area of a triangle is 1/2 base times height. Now, for an oblique triangle, it's not necessarily one of the sides is going to be the height, because we're used to solving for the area of a right triangle, because one of the sides would be the height, the other side would be the base, and we can do it that way. Now, if we look at both of these here, the height is, for one of them, for an obtuse triangle, it's outside the triangle. For an acute triangle, it's inside. So we'd actually have to find the height. And we could find that by h is equal to b sine of a. And using the law of sines, we have this here. Well, okay, that's what was moving. We get this here. Area for an oblique triangle is equal to 1/2 ab sine of c, which is equal to 1/2 ab sine of b. Or we can have 1/2 bc sine of a. Now, hopefully you kind of notice the pattern, yes? Because 1/2, what do we have? Side length A, side length B, sine of angle what? So we'd have 1/2 AC sine of, and 1/2 BC sine of. So when we're using this formula here, we really have the two sides and the angle in the middle, the angle between those two sides. And that's all we need to be able to find the area of an oblique triangle. So if we want to find the area of a triangle, triangular lot, having two side lengths of 90 meters, so we'll call this 90 meters, and 52 meters, and an included angle of 102 degrees. We want to find the area. Well, this would be what? 1/2 of 2 times plug it in. And we get 2,288.686. Either one. And that's it. Questions on this here? That's it. It's plugging in. 1/2 of 90 times 52 times 102, so 228,289, which we got. I just rounded a little bit further. That's it. And we can use this doing real-world application problems. So the distance from, so the course for a boat race starts at point A and proceeds in the direction south 52 degrees west to point B, and then this here. And so we can use it to find how far the distance between those points are. But I'm not too worried about that. Yeah, that's it. Super long lesson.